This video is about intercepts. Okay. The word intercept kind of sounds like the word intersect, and that's exactly what an intercept is when we're talking about linear equations. The intercepts are going to be where a line hits the x and the y axis. So we're going to have an x-intercept and a y-intercept. So we're going to start off easy and kind of take it further from there. So in number one, the x-intercept is where our line hits the x-axis. Remember, the horizontal axis is the x-axis. So it hits it right here. So our x-intercept is -1. The y-intercept is where it hits the y-axis, which is the vertical one, and that hits it right here. So our y-intercept is 2. Notice that I only wrote the numbers. I didn't write it as an ordered pair. I'd say for the most part, you usually will just write it with the number of the intercept. Occasionally, directions to questions might say to write it as an ordered pair. So just always make sure you're following directions on things. But for our purposes, we're just going to write the numbers. Okay, for number 2, it hits the x-axis right here. So our x-intercept is -2. And our y-intercept hits the y-axis right there. So our y-intercept also happens to be -2. Okay, that's a little bit too easy, so let's step it up a little bit. The good thing about intercepts is that we can use them to graph equations. So our first method of graphing equations was to make a table of values and plug x's in and figure out the y's, and it took a little bit of time. So here, this is our second method, which is using the intercepts. So right now, we're not looking at any actual equations. We're just looking to see, okay, if we know the intercepts, how can we use that to graph the equation? So number 3, it tells us the x-intercept is 4, which means we're going to find our axis, our x-axis, and put a dot at 4. We know the y-intercept is -2, so on the y-axis, it's going to hit right there. And we know those are 2 points on the line, so now we can take those 2 points and connect them with a line and put some arrows. And that would be our line. Okay, for number 4, the x-intercept is -5, which is over there. Our y-intercept is -3, which is right there. And now those are 2 points on the line. So we connect them like so. Okay, still a little bit too easy. Okay, we're not actually doing math yet. So let's bump it up one more time here. Okay, and this is actual skill we're working on here. So the x-intercept is going to be the x-coordinate of the point where a graph crosses the x-axis. Okay, I'm going to go up to our graphs for a second so we can look at them. Okay, here, I know we just wrote the numbers, but really this point was -1, 0. For number 2, its ordered pair would be -2, 0. For this one, number 3, it's 4, 0. This one for number 4 is -5, 0. Whenever you're talking about a point on the x-axis, it's because that point wasn't moved up or down at all, and its y-coordinate is 0. So that's the key to x-intercepts. Okay, x-intercepts happen when the y-coordinate is 0. So if we have an equation and we want to find the x-intercept, what we're going to do is replace the y with 0, and that's going to allow us to solve for x. For y-intercept, that's going to be the y-coordinate of a point where a graph crosses the y-axis. Same thing, I'm going to jump back up to the top for a second. Let's look at all the y-intercepts. Here, this one was 0, 2. This one was 0, -2. This one was 0, -2 also. And this one was 0, -3. So for y-intercepts, they happen when the x value is 0. So if we want to find a y-intercept, we're going to place the x with 0 and solve for y. Okay, so mathematically, it's really not going to be so bad. What the key is, though, you have to remember whatever intercept you're trying to find, you make the other variable 0. So if you're trying to find the x-intercept, you make the y 0. If you're trying to find the y-intercept, you make the x 0. Okay, so let's try a couple more examples here. So now we are actually going to graph our line. We're going to graph the line by finding the intercepts. And I did give you that friendly reminder of what we're going to do here. So for the first one, we're going to find the x-intercept. So we have 4x plus 2y equals 8. Let's find the x-intercept. Helpful reminder, that means the y is 0. So let's see what happens here. We're going to say 4x plus 2 times 0 equals 8. And what's super nice about this is that 2 times 0 is just 0. So it's kind of like this part of it just disappears. And all we're left with is 4x equals 8. And then if we divide both sides by 4, that means that x equals 2. For the next one, okay, we want to find the y-intercept. So same question, just finding the y. Now the x is 0. So 4 times 0 plus 2y equals 8. But now 4 times 0 is 0, and that part disappears, which means 2y equals 8. And if we divide both sides by 2, we get y equals 4. And now it's kind of just like what we did in numbers 3 and 4, where we knew the intercepts, so we put them on the graphs and we connected them. Here we just had to find the intercepts first. So x equals 2 means it's hitting the x-axis right there. Y equals 4 means it's hitting it right there. And now we can take those 2 points and connect them with a line. Okay, one more example. This one looks a little bit different. This one is in function form, whereas the other ones were not in function form. I will say for intercepts, it's actually a little bit easier when it's not in function form, when those x's and y's are on the same side, but we can still do this. So for the x-intercept, that means the y is 0. So we're going to plug the 0 in here. So 0 equals negative 2x minus 4. And unfortunately, nothing really disappears in this case, but hopefully you're recognizing that this is really just a two-step equation. So if I want to know what x is, I'm going to add 4 to both sides to get 4 equals negative 2x. And then divide both sides by negative 2, which means x equals negative 2. And that's our x-intercept. For the y-intercept, that means the x is 0. So y equals negative 2 times 0 minus 4. This technically just disappears, or we can just realize that negative 2 times 0 is 0. And then 0 minus 4 is negative 4. So that would mean our x-intercept is negative 2. And our y-intercept is negative 4. And then we connect them with our line. Okay, and finally, we're going to finish with what I like to call what not to do. Okay, I've seen it all. So this is what you shouldn't do when you're graphing intercepts. And yes, I have seen this. So for example, B, we got an x-intercept of negative 2 and a y-intercept of negative 4. And when I say graph your line, this is what I get sometimes. They put a dot right there. And if you're wondering where that dot came from, it's because they took the x is negative 2 and the y of negative 4 and put it together and made a single ordered pair. Okay, so the first example of what not to do is do not make an ordered pair with your intercepts. Okay, you're graphing a line, you're not graphing an ordered pair. Okay, the intercepts are where it hits the x and y axis. Okay, so do not make an ordered pair. That's bad. The second thing I see when you're trying to graph a line is they put the x-intercept at negative 2. So far, so good. The y-intercept at negative 4. So far, so good. And then they connect the dots. While this is almost correct, okay, hopefully you can see that they graphed a line segment. So we do not want a line segment. Okay, really, they should have connected all the way through those points and put the arrows. Okay, don't just connect the dots and stop. Okay, so as a reminder, when you are finding intercepts, you plug 0 in for the other variable. So for x-intercept, you make the y 0. For y-intercept, you make the x 0.